Okay, today's video is all about triangles, and I know that's a shape that you've known for a very long time. Obviously it has 3 sides and 3 vertexes, but we're going to get more in depth with some triangle work here, looking at the side measurements as well as the angle measurements. Go ahead and jot down the title on the top of your notes. Take out these materials. You need your spiral notebook, and you're also going to need a calculator. It doesn't have to be anything fancy. Any plain old calculator will work. And then here are some vocabulary words that you're going to come across within this video and within your study with triangles. You should know scalene, isosceles, and equilateral. All of those words deal with triangles based upon the side measurements. And then you've got acute, obtuse, and right. And that will name a triangle based upon the angle measurements. You also will hear the word theorem. And theorem is just like an idea or a study of something. Once you have all this information down, go ahead and unpause the video and carry on with me. All right, triangles. Triangles have 2 names, just like you have 2 names. You have a first name and a last name. Triangles have 2 names as well. You can have a name based upon their angles or a name based upon their sides. So take a look at this triangle here. Do you see how two of the sides are the same? Okay, well, what word means a triangle with 2 sides that are equal? Isosceles. And now let's look at the angle measurements. If I told you that they are all the same angle measurements, if they are all 60 degrees, if they're all 60 degrees, all of the angles are small, so it's called an acute triangle. So we can call this an acute isosceles triangle. Take a look at the next one. Look at the side measurements and write down its name. And now also look at the angle measurements and write down its name. You should have gotten an acute equilateral triangle. All the angles are acute and the sides are all equal. Take a look at this one. Let me put some angle measurements in. Let's say this one was 85 degrees. And this one was 70 degrees. And let's see. I don't know. 70 and 85. Looks like this would be like 25. I'll double check that one. Go ahead and write a name for this one, and this one. And I'll come back to that one and put a measurement in there to make sure it's exact. Yep, 25 is right. All right, hopefully you have all these names. This is a 70. So that's 70, 85, and 25. They're all small angles, so that's an acute. And looking at the sides of the triangle, they're all different, so it's scalene. So it's an acute scalene triangle. 2 names, acute and scalene. This one, you have a right angle, so it's a right triangle. And 2 of the sides are the same, and I can tell 2 of the sides are the same because of the 2 tick marks. They both have 1 tick mark each, so they match. That means this side matches this side. So we call it a right isosceles triangle. And then finally over here, again we have a right triangle. And all of the edges are different, so it is a scalene. And finally, we've got 20, 150, and 10 degrees. Notice the obtuse angle inside there. So we're going to call this an obtuse triangle. And looking at the edges, they're all different. So again, it's scalene. So we have 2 names for each triangle. All right, let's take a look at, if you have a triangle, how can we figure out some different pieces of information? Now, the sides of a triangle are a little bit tricky to figure out, but if you have tick marks, that can be very beneficial to you, and that can give you some really good clues. If the directions or the description of it says it's drawn to scale, then of course you could grab a ruler and you could actually measure it. But many times those triangles are not drawn to scale, so you won't be able to use a ruler to measure. Or hopefully they'll give you some of the information and then you can just use that to help you figure out the angle measurements. But let's take a look at this one here. You've got 7 and 5, but you have a missing one here. Now, it's not drawn to scale, so you can't take out a ruler and measure it. There's no tick marks involved. But what we can do to figure out this method is called the Pythagorean theorem. And you would use a squared plus b squared equals c squared. So we would take the two sides, square them, and that will help us figure out what's left. So this would be 7 squared plus 5 squared equals c squared. Well, grab your calculator, and if you don't have a squared button, you could always times it by 2. So you've got 7 times 7, which of course is 49, plus 5 times 5, which you know is 25. So go ahead and add those two values together and you get 74. What number squared will give you 74? That can be a little tricky, and that's where you use what's called the square root button. It looks like this. On my calculator, it's here in yellow. So I'm going to do the square root of 74 and hit enter, and I actually get a decimal. 8.6, and so on. I'm going to round to the tenths place here. This is called the Pythagorean theorem. Theorem is the idea. The idea is that if we take this number and square it, plus this number and square it, it will equal this number squared. You do want to remember this part right here. Okay? Now take a look at this one. This one's a little different. We have tick marks, so that is very, very beneficial to us. Notice this side has one tick mark, and so does this side. That is a huge clue. Because they have the same number of tick marks, that means they measure the same exact amount. So if this one's 6 centimeters, that means this one is also 6 centimeters. Those tick marks can be very beneficial. Over here, do you notice how they all have the same tick marks? That means they all have the same measurement. Take a look at this last one. Do you notice anything about the tick marks? These two sides have 2 tick marks. That means those two are the same value. This one has a different number of tick marks and therefore has a different value. So how big do you think this one is? How long do you think this side of the triangle is? You got it, 12 inches. If you didn't copy these examples down, go ahead and pause the video and do that. And make sure you write off to the side the information about the Pythagorean theorem and the tick marks, because that's super important that you're going to want to remember later. Alright, now we can also use different pieces of information and clues to help us figure out the angle measurements inside of a triangle. And this is called the Triangle-Sum theorem. And I will write that maybe right here for you. You're going to use what you get from your picture, your design, and help you figure out what's missing. Looking for isosceles triangles can be very helpful to you, and also remembering that all the angles equal 180 degrees, and that's the triangle-sum theorem. Okay? Take a look at this triangle right here. Do you see how they both have tick marks? Well, not only does that mean that the sides are the same, but it also means that the angles at the bottom are the same. Those little tick marks tell you that those two angles will be the same. So if this one's 65, that means this one is also 65 degrees. Now take a look at this one. This one doesn't have any tick marks to help us. So we're going to use the triangle-sum theorem to help us figure out what's left. Now we know that we have 2 angle measurements already, and we want to find out the missing number. So we know that all together they will equal 180. So if we subtract what we already know, that will help us figure out what is left. So with your calculator, you're just using the subtraction button. Go ahead and subtract 70 and 65 to figure out what's left. what's the remaining angle measurement? Did you get 45 degrees? All right, take a look at this one. It has tick marks, so go ahead and see if you can find the missing angle measurement. We're going to look for this one right here. Did you get 15 degrees? Very good. Now, can you also use the triangle sum theorem to help you come up with this one? Sure you can. You have 15 and 15, and now you have to find out what's left. You really have to be kind of a detective to work these questions out, figuring out what clues can you use to help you. So start with the 180, and we're going to subtract the two 15-degree measurements we already know. And what does that leave you? 150 degrees. All right, go ahead and try this one. See if you can be a detective. Pause the video and then come on back and I'll tell you your answers. This is a common question. Do you see the 90 there? And do you see the two tick marks? That means these two are exactly the same. So if we take 180 and subtract the 90 for the right angle, what does that leave us? We have 90 degrees left, and we have to use that 90 degrees for two angles. So if they're going to be the exact same amount, what number plus itself would give you 90? Did you get 45? 45 degrees each. Altogether, that equals 180. All right, let's go ahead and try the last two, and then come on back and I'll give you the answers. You should have gotten 40 degrees here. And did you notice that this equilateral triangle are all the same? That means all the angles are the same as well. So if you have 180 degrees, and you have three angles that will add up together to equal 180, what number plus itself again will give you 180? Or what's 180 divided by 3? 60 degrees. We're going to do more practice with the triangle sum theorem and with finding different values for your length measurements with isosceles triangles as well. We'll see you soon.